Afternoon. So today I will discuss WTB approximation method. WTB approximation approximation method. This is also very important question. This one, 10 marks. Okay. So this is the WTB approximation mean. Uh, WTB mean vent gel, corners, vent gel corners, brilliant, vent gel corners and brilliant. That is the WTB approximation method. That is the scientist name, Amma. That is the WTB means scientist name here. W mean Wetzel, Wetzel, and K mean Tranners, K mean Trammers, and B mean B mean Bri- Brilliant. This is the WTB approximation method. So this is the WTB approximation method. We have discussed. We have useful the approximate and the treatments of the system with the slowly varying the potential. That is the potential which the remains almost constant overall the hello everyone. WKB approximation method. This is so here this is the WKB approximation method. The based on the expansion of the wave function in the power series of H card, in the power series of H card, in the power series of H card, power series of H card. The zero first and second power of H card, first and second power of H card respectively, give the classical, quantum, and higher order result. Higher order result. It is also, it is also is classical approximation method is since that gives the classical result when the H card. This is the H card. This is the H card. So the H card is the zero result when H card is set is zero. This method is applicable especially when the potential is slowly varying. That consider a particle of mass m. Consider a particle of mass particle of mass m, particle mass m, and total energy is equal to g, is equal to g. Moving in the time independent potential, moving, 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 moving in a time, time independent, independent potential, potential, independent potential, independent potential, V of x, V of x. The Schrodinger equation, the Schrodinger equation in one dimensional is Schrodinger equation, Schrodinger, Schrodinger equation, Schrodinger equation, one dimensional, one dimensional, one dimensional is, one dimensional is, one dimensional is a formula d square psi by dx square plus 2m by h card square into e minus v of x, v of x, psi of v of x into psi is equal to 0. That is equation 4.1. Okay. So in the particle is moving in the region of constant potential, the region of constant potential, the solution of the above equation of the form in the particle in moving in the region of constant potential, the solution of above equation of the form, that is the psi of x is equal to e plus or minus ikx, ikx, that is 4.2. Here k is equal to under root of 2m by h card square into e minus v of x, v of x, v of x. This is equation 4.3. However, the v is not strictly constant but varies slowly as the function of x. The the function of 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 x, the function of x. For such system, the WTB methods provides as a approximation treatment, and we might consider a solution of following the form psi of x is equal to e power of is of x by h dot. This is equation 4.4. Equation 4.4. Okay. So next, the v of x is unknown complex. Here, v of x, sorry, s of x, is unknown, 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 unknown complex, unknown complex complex function, complex function, and and complex function and is not proportional to, is not is not proportional to proportional to x, proportional to x. The function of the function of the function of the function of s of x and real and the determine the and real the determine the Schrodinger equation, 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 the Schrodinger equation of the regions, of the regions, regions, E, less than, sorry, E greater than, E greater than, E greater than V of x. E greater than V of x can be written as, can be written as, can be written as d square psi by dx square plus k square psi is equal to 0. This is equation 4.5. Okay. So here the kinetic energy formula, you have to take the kinetic energy formula is equal to, here p square is equal to h square k square. Okay. Simplify this. Simplify this 2m minus e minus v of x into psi of x. Okay. So here equation v of x, that is the differentiating equation 4.4. We'll take the equation. This is differentiating 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 equation 4.4 with the respect with respect with respect with respect to x with respect to x twice. Okay, with respect to twice. So this is d psi by dx is equal to, you are differentiating this equation. Which one is the equation 4.4? You will take this. Which one here? 4.4. You will take this one. This is the differentiating is the twice. This is the only its composition. This one exponential. You know, it's exponential. You will take the differential equation. So this is d psi by dx, d psi by dx, I by h cot s dash e power I s of x by h cot is equal to I by h cot into psi of x. Okay. Then twice you will get the twice differentiating. So here d square psi by dx square is equal to I by h cot e power I s of x by h cot s double dash minus I h cot square s dash square s dash square s dash square e power I s of x is equal to h cross. This is the equation. Simplify this one. Finally, d square psi by dx square is equal to I by h cot I by h cot You will take the s dash s double dash of psi of x minus 1 by h cot square s dash square psi of x. This is equation 4.6. 4.6. So let us plot the equation 4.4 and equation 4.4 and 4.6 into 4.5. 4.5. Okay? These are equations. So finally, 4.4 and 4.6 into 4.5. That is the simplify the equation. I by h dot s double dash minus 1 by h dot square s1 square plus k square psi of x is equal to 0. So I by h dot psi double dash minus 1 by h dot square 1 by si square plus p square by h dot square into psi of x is equal to 0. This is simplify the ds by dx whole square minus I h dot d square s by dx square minus h dot square k square is equal to 0. So s dash square minus h dot s dash minus h dash square k square k square is equal to 0. This is equation 4.7. 4.7. So this is the equation 4.7. The above nonlinear equation, the above nonlinear equation allows the developer approximation method. The solution of equation, the solution of this equation gives the form of the function s of x, s of x. The expanding the s of x in the power of h dot and keeping only the lower order term, the we get we get we get s of x is equal to psi naught of x plus h dot psi 1 of x plus h dot square by 2 s2 of x plus dash dash. That is, you will take the 4.8 equation. This equation you are substituting in the equation 4.7. This equation substituting 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 equation 4.8 4.8 in 4.7 comma we get. Okay. So here the s dash of x plus h dot s1 dash s1 dash of x plus h dot square by 2 psi dash of psi 2 dash of x plus uh, psi 2 of x whole square minus I h dot into s double dash naught of x plus h dot s1 s1 of x plus h dot by h dot by 2 h dot by 2 h dot by 2 s double dash s2 double dash of x plus dash dash plus double dash, okay, minus 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 p square is equal to 0. This is equation 4.9. 4.9. equation 4.9. Okay. So here the coefficient of the various power, the the equation, the coefficient, coefficient, coefficient of various of h dot, we get, we get S naught dash p square is equal to 0, 2 S naught dash S1 dash minus I H dot 0. Here S1 dash square plus 2S dash S1 dash minus IS dash is equal to 0. This is the equation 4.10 or 4.11. See the equation 4.12. Okay. So equation 4.12. Here the coefficient of each power of the coefficient of the coefficient the coefficient of each power each power each power of h dot, the vanish separately 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 from equation 4.10. From equation 4.10 we obtain we obtain we obtain which one is the equation? This 4.10. You will take that equation 4.10. So that is the simplify here. Psi naught dash square is equal to p square is equal to h dot square k square. So this is the equation. We will take this one equation. Equation your coefficient power of vanish. That is the from the equation. You simplify this one amount. So here this equation you observe this is the kinetic energy formula is given here. So kinetic energy formula already I am telling this. Where is the kinetic energy formula? This one. You see this. This is the kinetic energy. The p square is equal to h dot square k square. That is equal to 2m into e minus v of x into vx, psi x. So that equation is simplify this. Finally, we'll take the three equation that here not dash minus p square is equal to 0. That is the equation 10, equation 4.10. This is also same 4.11 and 4.12. That is the coefficient of the power of vanish is the separately equation. We will take the 4.10 equation. That the sin naught is equal to sin naught of is equal to p square is equal to h dot square minus k square. So this here what is the formula here? P square is equal to h dot square minus h dot square and k square. So here you also will take that formula. Okay. Here sin naught square that one. That is the sin naught square amount. This is sin naught square. Okay. Sin naught square. So here sin naught square is equal to sin naught dash square is equal to p square is equal to h dot square minus h dot square and k square. Okay. So that is equation. You write this here. Equation. What is that? S not dash is equal to plus or minus h dot k. Okay, now root is the cancel. That was square is the cancel. Remaining the s naught dash is equal to plus or minus k h dot and k. That is equation 4.13. Okay. So next to integrate in the above equation mean integrating 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 uh the integrating this equation the above equation integrating the above equation. Which one the above equation? 4.13. So we get the psi naught of x is equal to plus or minus integral of h dot k of x dx is equal to plus or minus integral of under root 2m 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 e minus v of x v of x v of x v of x dx dx is equal to dx is equal to dx is equal to plus or minus integral of p integral of p integral of p of x and dx x and dx. That is equation 4.14. Okay. So this is the 4.14 is the equation. Next, the from the equation 4.14, 4.11 from equation 4.14, 11, 4.11, we can find the S1. We can uh, we can find the we can find the we can find the we can find the S1 S1 which is 2 H1 is 2 in fact imaginary 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 by following the following the equation following following the equation. So that is S dash S1 S dash is equal to I by 2 S double dash not S double dash not by S not dash is equal to I by 2 I by 2 dk by dx by k 15 equation 15. So here where k is equal to s naught dash k is equal to s naught dot. This is equation integrated the above equation. So this is the equation also integrating. So integrating 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 the above equation the above equation equation 4.15, we get S1 is equal to I by 2 large K. S1 by 2 large K extends to S1 is equal to large K proportional minus power of 1 by 2. This is extend to exponential of IS1 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 is equal to K power of minus 1 by 2. This is 4.16. The second derivatives remains the relativity. The small of slowly varying the potential. Therefore, we can draw the third and higher order terms in second terms equation in 4.8 in equation 4.8, and we can reconstruct the wave function to the order of the approximation from equation 4.4 by using equation 4.13 and 4.16. Equation 4.13 and 4.16. 4.13 and 4.16. If we get the equation, psi of x is equal to e power of is of x by h dot is equal to expansion I by h dot into s naught plus h dash s1 s1. This is similarly the psi of x is equal to e power of I s naught h dot into I s naught by h dot into e power of I s1 of x is equal to 1 by root k e plus or minus I integral of k of x k of x dx dx. This is equation 4.17. 4.17. So this is the psi of x, that is the simplified equation integrating that psi of x is equal to 1 by root k of x exponential of plus or minus I integral of k of x dx. That is also equation 4.18. 4.18. So next is this one, 4.18. Psi of x is equal to 1 by root p of x exponential of plus or minus I by h dot integral of p of x dx dx. This is equation 19, 14.19. The basic solution of the WTB approximation method, WTB approximation method, solution of in the WTB approximation method, the solution in the in WTB approximation for the equation 4.5. So now we can write the general form of the solution that can be built from the basic solution. This general solution is the superposition of the two basic solutions, and the form of will be the form of will be the form will be the form will be which one? Psi of x is equal to a by under root of k of x exponential into I into integral of k of x dx plus b by under root of k of x exponential of minus I integral of k of x dx. K of x dx. This is equation 4.20. Okay. So here A and B, this one. Here A and B, the arbitrary constant. The positive exponential and negative exponential corresponding to the wave propagating in the opposite that the positive and negative directions respectively in the allowed the region allowed the uh region E greater than V of x, which is called the classical allowed the region and classical region. Moreover, the first phase grows as the x grows, while the second phase becomes more negative and the x grows. X grows. So that is in the similarly manner we can write the solution of the region, the right solution of the region. The similar manner, the similar manner we can write that we can write the solution for region E less than V of x. E less than V of x, which is known as the classically forbidden region and non-classical region, which is which known as known as known as classically 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 forbidden forbidden region forbidden region non-classically non-classical non-classical region psi of x is equal to c by under root of k of x exponential into into exponential into integral of k of x dx plus d by d by d by d by root k of x root k of x exponential minus k of x dx k of x dx 4.21 is the equation 4.21. This is the first term. So this is the first term here. The first term is exponentially is increasing as the x grows, whereas the other one in the exponentially decreasing as x grows. The point at which e is equal to v of x, the point the point the point the point the point exponentially the point exponentially e is equal to v of x is taller the classical turning point because classically the particle would stop at this point and term back to move in the opposite direction. The validity criteria of WKB. Next one, this WKB approximation. This is equation the exponentially okay. V is equal to v of x. This one is here validity 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 criteria of WKB approximation. This is approximation. Okay. So this is the approximation. The WKB wave function, equation 4.4, the WKB wave function, the WKB wave function, equation 4.20 and 4.21 are obtained by restricting the expansion of s to the first power of h card s to the 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 which one first power s to the first power power of power of h star. The since the contribution of higher power of h star since the country contribution contribution is for the since the contribution country contribution of higher higher power power of h star higher power h star in the expansion 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 of s in negligible s is negligible. Okay, s is negligible. So the from equation 4.11 and 4.12 we can write we can write we can write s1 dash s1 dash is equal to I by 2 s double dash s naught double dash by s naught dash s naught dash. This is equation 4.21 of A. Okay. Since s naught dash is equal to s naught dash is equal to s naught dash is equal to u is equal to p. You say this. Okay. So can we write can you write the equation? Can you write the equation? S1 dash double dash is equal to 1 by 2 P double dash by P minus P dash square by P square. P square. This is equation 4.21 B. 21 B. 4.21 B. Okay. So here 4.21 B. Next here S1 double dash is equal to IS1 double dash by IS1 double dash minus S1 square by 2 S naught dash dash is equal to 1 by 2p into 3p dash square by 4p square minus by 2p. C is 4.21 of C. Since we use the restricting to the first power of h star, the h star first power of h star, that is h star s1, that is h star s1 is leads to the leads to the ratio H dot S1 by S naught. S1 by S naught. So should be small if the should be should be a small if H dot S1 dash by S dash is the small since the S naught is mono, monotonic monotonic is the increasing function of x, monotonic is the increasing the function of x. If we valid the turning of point, the turning of point at which p is with the point p, that is h dot s1 dash by s naught dash less than or equal to double less than or equal to 1 and modulus of h dot square s2 dash s naught dash to 1. This is 4.21 D. The above condition implies the above condition, the above condition, the above condition, the above condition implies, the above condition implies that that h dot psi 1 dash by h naught modulus of h dot psi 1 dash by psi naught dash is equal to h dot p double dash by 2p is equal to lambda is equal to lambda is equal to lambda equal to lambda dp by dx dx dp by dx is the lambda by 2p amma. Lambda by 2p into lambda by 2p here dp by dx by dx is equal to h dot sorry lambda by 4 into e minus v dv by dx double less than 1. This is equation 4.21 of E. 4.21 of E. Next is the simplify the equation modulus of h dot square s 2 dash by s naught dash is equal to h dot square by 2p square into 3p dash square by 4p square minus p double dash by 2p into less than double less than 1. This is equation 4.21 EF. Okay. So here equation from equation from equation 4.21 G, it is clear, it is clear, it is clear that WKB approximation is valid, approximation is valid only when the rate of charge rate of charge charge rate of charge of d broadly d broadly wavelength d broadly wavelength. Okay, this is the one of the particle must vary in the only straightly or the distance of the order of its size and in the region that the does not include the classical turning point. Similarly, condition we can be obtained from of the equation 4.21 f. This is the equation. Simplify the finally. So finally, this is equation is so this is the final the equation. Okay. So here the equation related. So next, so next, so next, so next is the equation question. General angular momentum. General. This is the totally is only WTB approximation method. This is a very important question. Is okay. So this is the totally the given the simplify the equation number. So next to general angular momentum. Next one. General angular momentum. Okay. Unit 5 this. Unit 5. So general angular momentum consists of you find out this number of type of the angular momentums. So the number of experimental result such as the spectra of alkali metals, anomalous G1 effect, G1 effect, G1 effect, and state. The class garden is a experiment that could be explained only by the involving the concept of the electron in the atom process of additional in-strict angular momentum involving of integral quantum numbers. So that is the general angular momentum. The definition of angular momentum, the definition of the angular momentum, angular momentum, angular momentum, L is equal to R into P. Okay. So is not the including of integral quantum numbers, and therefore we take the definition of general angular momentum. We take we take we take the we take the take the definition 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 sorry the definition take definition of general angular momentum. General angular momentum. The general angular momentum, 1 minute. So general angular momentum. So general angular momentum, general angular momentum is equal to J. Okay. That is J is equal to L dash plus S. L dash plus S. Okay. So this is the equation. This is the form of the general angular momentum. So here you calculate the formula, the angular momentum in the general J. The angular momentum, general J. So here the definition of angular momentum, this L is equal to L into P. Sorry, L is equal to Rm. This is R. That is Rm. Okay, is the R. So the angular momentum L is equal to R into P is not general into the include of integral quantum numbers, and therefore one may take the definition of general angular momentum. The symbol of J is used for the general angular momentum. The component of J and the operators J square, J plus, J minus. The operator, the operator, the operators, the operators. So the operators J square, comma, J plus, comma, J minus. Okay. Away with all the commutation, the relation between the operators, the relation between the derived the operators, the derived the operators, derived the operators, which one? L comma, L square comma, L plus and L minus. Okay, L minus. This is the commutation relation or this commutation commutation relation are relation are relations are relations are bracket jy comma jz is equal to I h dot jx. Here jz comma jx is equal to I h dot jy. Okay, and comma jx comma jy is equal to I h dot j z. This is the simplify the yr came this I h dot jx and I h dot jy and I h dot jz. This is the equation the simplify amma. These are depending on the operators, the angular momentum operators, linear momentum operators. That is simplify the equation here. You explain the next class also you totally explanation part. This depending on the this equation totally. So that is the what is the meaning of mean. For example, jx comma jx is equal to is the 0. Jx comma jy is equal to I h dot I h dot jz. This is just simplify the equation totally. That is a dependent on the you will came. Is simplify the equation is came. This finally is came. This one here and this and this. Okay. So three equations the equation simplify that is depending on the angular momentum and linear momentum. Okay. I'm telling that this is totally explained part. One question is came here. That is totally I'm telling the next class. But first you know this point only. What is meaning this? Jx comma jy comma jz is equal to I h dot jx and jy comma jx is equal to I h dot jy and jx comma jy is equal to I h dot jz. Okay, that is the equations value. So here jx, jy, jz do not match only commute value. So here jx comma jy comma jz do not mutually commit. Okay. So the square of the angular momentum is the scalar operator. Hence the commute with the jx, jy and jz. Jx and jy and jz. That is j dash square is equal to jx square plus jy square plus jz square. Here already telling this. Here what is meaning this is a j cap square comma j cap is equal to 0. J cap square comma j cap is also 0. J cap square comma jz So 0. Okay. Here, this is the angular momentum formula. Next, linear momentum equation is also, this is also same. This is linear momentum. Linear momentum. Linear momentum is also uh, linear momentum. That is also same. Jx Jx square comma Jx Jx is equal to 0, 0. Jy Jy comma Jy is equal to 0. Jz Jz comma Jz is equal to 0. This is the linear momentum equations part. So this both value and angular momentum and linear momentum, they are simplify the equation here. Jx square comma Jy is equal to Jx comma Jy. Okay. So you simplify this, the finally is the simplify equation. This multiply both values, the multiply this. So not multiply this, we are simplify this equation. Which one is the formula? This Jx into Jx Jy plus Jx 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 Jy into Jx. That is here Jx into I start J Z plus I start J Z Jx. So is equal to I start into J X J Z plus A Z plus J Z J X Z. This is J's value, J's Jy value. Here is also J's Jy value. You will take this equation only. Which one here? You will take this one here. What the I start Jx and I start Jy and I start Jz value. You will take this both value here. Jx and Jy value. Here Jx and Jy value. You will take this value. Okay. So that is up to your formula. This. Understood? So here I start here I start is also will take here both values are common there. After you will take I start values are common. After J x square comma Jy. So this is not simplify here. This is the finally I start Jx Jy and Jx Jz. So here what is formula here? Jy. Understood? So this equation is a simplify here. You will take this equation J square x and Jy value. This is also both three equations also simplify this concept. Here Jy and Jz, here Jx, Jz and Jx, here Jx and Jy. This is also with three equations you are simplify this concept. Okay. So three concept value mean here jx square value jy. Okay, here jx square value you write this jx comma jx into jx comma jy. So here jx value both two values is multiply this both side. Okay, jx value comma into jx into jy value plus jx jy into jx. So totally jx to jy value, which value there? This value here. This value are substitute here this equation. Okay. After you common, which value is a common? I h cut value is common. So finally is came jx, jz and jz and jh. So here jx, jz plus jz, jx is equal to jy. Understood? So you write also here bracket jy is equal to jx, jz plus jz, jx. Okay. So that is the equation. Similarly, this is also same. This is also same. I h cut. Similarly, this is also same. I h cut into jx, jz plus jz, jx. Okay. So here is also I h cut, jx, jz, jx, jz. So this is also which value here? This is, I think, is a mistake. Here, Z also Y. I think this is a Y. Also Y. Okay. So here J X. Understood? So similarly, this is also J X is equal to J Y J Z plus J Z J Y. Okay. So similarly, what is this? Here J Y square comma J Z is equal to I H cut into J Y J X J Y J X plus J X J Z J Z. Okay. This is also you write this I H cut J Z. Understood? So this is the equation. Clear? This is also here equation. Here is also this equation. Clear? Huh? So this is the angular momentum in general J. Okay. Next one is eigenvalue of J square and JZ value. Simplify that is the land person is at 10 marks person. We will see that. Next to eigenvalues of Jx and Jy. Eigenvalues of Jx and Jy and eigenvalues of J plus and J minus. J plus and J minus. So this is a very important question here. Next one is eigenvalues of Jx and Jz, Jx and Jy. Okay. So this is also 5 marks question. Okay. So we have three angular momentums. Here we have three angular momentums, three angular momentums, three angular momentum operators. This one, three angular momentum operators, that is Jx, Jy, Jz. Okay. So here Jx, Jy value is equal to, already you know that value before equation I am telling that is also same. Here that value, three values you write this one. Which one is the three momentum of angular momentum operators? Three angular momentum operators Jx, Jy, Jz. That is Jx, Jy is equal to I h start Jz, Jy, Jz is equal to I h start Jx, J Jz, 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 Jx is equal to I h start Jy. Okay. So this is the three angular moment. Here total angular momentum operator, the total angular momentum operator, the total angular momentum operator, the total angular momentum operators, J square is equal to Jx square plus Jy square plus Jz square. Okay. The simultaneous eigenvalues, the simultaneous the simultaneous the simultaneous the simultaneous eigenvalue the simultaneous are eigenvalues are only the possible for J square and one component